Hi there, this is our factoring video. So it's going to be a little bit different. The video note sheet is going to be a little bit different. It's not going to be in the standard form we've done, and I apologize. It's kind of had to scan it in, had to do this manually. So first of all, how do we factor? When we factor, we must put the equation f of x. It must be in the ax squared plus bx plus c form. So we can identify what A, B, and C are. So this is the main formula that we're going to start with. So this is when A is positive or negative 1. And we'll get to that more in a second. But first of all, I want us to just identify, we're going to assume for now that A is positive 1. When that happens, we're going to put C here, B here, and then we're going to find these two values, okay? So we're going to start with a little chart, and we're going to call this C, K1, K2, B. C is going to be the product, and B is going to be the sum. So C is going to be the product of K1 and K2. B is going to be the sum of K1 plus K2. All right, so write this down, and we're going to try a chart. So you see on your sheet, on your video note sheet, so you've got some numbers here. I just didn't have time to write boxes, but what we're going to do is we're going to put them in a rectangular box with 4 rows. So the first number is going to be C. B is going to be 7. So what we need to do is we need to find K1 and K2. So we need to find two factors of 12. So we're going to do factors of 12 whose sum is B. So we can make a list. 12 is 1 times 12, 2 times 6, 3 times 4, okay? So because it's positive, they're either both going to be positive or both negative. Since they're the same sign, the sum is going to be adding them together. So which one gives, whoopsie, sorry, I can't add. This is 7, this is 8. Which one gives me 7? 3 and 4, so I'm going to have 3 and 4. Does the product of 3 and 4 equal positive 12? Yes, it does. Does the sum equal positive 7? Yes, it does. So pause this, take a picture, write this piece down and this piece down because I'm about to delete it. Okay, so now we're going to continue. We're going to do the rest of this sheet here and finish and do the same thing to all these numbers. So 20 and 9. So the 20 is C and 9 is B. So what two factors of 20 will give the sum of 9? 4 and 5. So let's check it. Does 4 times 5 equal 20? Yes, it does. 4 plus 5 equal 9? Yes. Okay, so I want you to pause it and do 24 and 10, do the rest of them, and negative 5, and 84, and negative 25, negative 28, and 3. Actually, I'll do this one with you, and I will allow you to do the other rest by themselves. So what times what equals 28? So we have 4 and 7. Okay, well, because this is negative, if I put 4 and 7, 4 times 7 is equal to negative 28? No, it doesn't. So I'm going to make one of these negative. Now, does the product equal negative 28? Yes, it does. Does the sum equal 3? Oops, no, it doesn't. So this has to be positive, and this has to be negative. So this is K1 and K2. Doesn't matter which is which. Just these two are K1 and K2. So does the product equal negative 28? Yes. Does the sum equal 3? Yes. Pause this. I want you to do the remaining 3 that aren't done. Okay, so now we're going to go to the next page, factoring. So we're going to, again, we start by putting it in standard form, ax squared plus bx plus c. Now, we're going to start off when A is positive 1 or negative 1. So we're going to use that same chart that we had and do C and B and K1 and K2. So remember, the product of K1 and K2 have to equal C. The sum of K1 plus K2 have to equal B. So if you didn't write that down earlier, make sure you write it down now. Now when A is 1, we proceed directly to here. Okay, if A is not 1, you must factor out, for example, if you have negative x plus square plus 2x minus 1, well, A is not 1, so I'm going to factor out a negative 1. So I'm going to get x squared minus 2x plus 1. Okay, now our A is 1, our B is negative 2, and our C is 1. Okay, so we must factor out negative 1 if A is not 1. So the first step we're going to do is we're going to put it in standard form, make sure A is positive 1. We're going to write our little x, and we're going to, so the first thing we need to do is we need to, 1, identify A, B, and C. Step 2, we need to find K1 and K2. Once we find K1 and K2, that's this little chart that we did here. Okay, so we have to put C here and B. We find two numbers, two factors of C whose product equals C and whose sum is B. So it's exactly what we did on this first page. So we first we identify A, B, and C, then we find K1 and K2. Once we find K1 and K2, we check to make sure K1 plus K2 equals B. Right, so K1 plus K2 equals B, and K1 times K2 equals C. So we check that. Once we do that, then it's simply x plus K1 times x plus K2, and now we factored. How do we check if we factored correctly? We do the FOIL method. Remember, first times first. Oops, sorry. So ignore this line. I'm going to do it in blue. First times first, outer times outer, inner times inner, and last times last. And then you combine like terms, and you should get the original quadratic equation. So let's try one together. So let's try x squared plus 14x plus 24. So is it an ax squared plus bx plus c? Yes, because we don't have it equal to a number or to y. So let's identify what is a, b, and c. So a is 1, b is 14, and c is 24. So now we make our little x, and we say 24 and 14. So we're going to say what two factors of 24 has a sum of 14. So I'm just going to try, so 6 and 4. So 6 times 4 is 24, but 6 plus 4 is 10. What about 2 and 12? 12 times 2 equals 24? Yes. 12 plus 2 equals 14? Yes. So my K1 is 2 and 12. Does it matter if I do 12 here and 2 here? No. As long as the product equals 24 and the sum equals 14. So now I have x plus 2 times x plus 12. And then I'm going to FOIL it to make sure I didn't make any bad math errors. So first times first, outer times outer. Don't forget about your signs. This one was an easy one because it was all positive. Inner times inner. And last times last. (2x), 12x, sorry. So first times first, outer times outer, inner times inner, and last times last. Then I combine like terms and I get x squared plus 14x plus 24. So I get exactly what I had here. Okay, so pause it, do 1a and 1b on your own. I know it's kind of hard because this is messy. So this is 1a and this is 1b. All right, so factoring when a does not equal to positive or negative 1. So that's going to change how we do things totally. Oops, I need to do here. Okay, so how do we do when a is not positive? So the first thing again, so when a does not equal plus or minus 1. So we put it in standard form. Make sure it's ax squared plus bx plus c. And then we're going to identify a, b, and c. And now our formula changes slightly. So we have ac, b, k1, k2. So the change is here. It's the product of a and c. We still are going to take the product of k1 and k2. So ac is going to equal to k1 times k2. And b is going to equal to k1 plus k2. So write this down because it's not in there. This part is, but this isn't. Okay, so this is a little different. So now we're going to have three methods. We're going to have the grouping method, the box method, and the California method. So let's start with the grouping method. We're going to use the same problem for all three, and we're going to keep it up here. So I'm going to change this in, and I don't know why I use n to x, just because not to confuse things. So 5x squared plus 19x plus 12. So the first thing I'm going to do is I'm going to identify what is a, what is b, and what is c. Then I'm going to make my little AC. So a times c is 5 times 12, which is 60. And then b is 19. Okay, so I'm going to just make a third layer so we don't erase this. All right, so now that I'm here, what's the next thing that I'm going to do? So again, I'm going to find K1 and K2 just like I did before, and it's going to be 4 and 15. So does 4 times 15 equal positive 60? Yes, it does. Does 4 plus 15 equal positive 19? Yes, it does. So now I'm going to keep the quadratic term and the constant term. So I'm going to write 5x squared plus 12. Now, in the middle, now I'm going to put my linear term and do plus 15x plus 4x. It really shouldn't matter which one goes to which. However, I know that these two, we're going to group two terms together. So I'm going to group the first two terms together and then the second two terms. Now, caution. This is why I don't like the grouping method. This is the only, you have to really know your signs and how to group correctly. If this is positive, then you're good. If this is negative, you're going to attach that negative to this term right here and replace this with a plus. So then you will factor out a negative later. So let's just keep going. So I'm going to take these two terms, so they have a common factor. They do, and it's going to be what? It's going to be, let's see, I like to play with the color wheel. So it's going to be 5x. So I'm going to factor out a 5x, and I remember when you factor out, you're dividing each term by it. I've put them in parentheses. So I'm going to get x plus 3. Here, I'm going to factor out a 4, so I'm dividing by 4. So I'm going to positive 4, so I get x plus 3. So do you see I went from 4 terms down to 2 terms? One whole term. Remember, it's glued together because of this multiplication. All right, so now it is 5 times x plus 3. 4 times x plus 3. So I've got 3 factors here and 2 here. Do I have any common factors between the two terms? Yes, it's what? X plus 3. Remember, it's tied together. That is my GCF. So that's what I'm factoring out. So remember, it's what you're doing when you factor out. So this cancels out and you're left with 5x plus 4. And that is what it factors out to. So how do we check this? We're going to FOIL it. So you got to remember how to FOIL. So first times first, 5x squared, outer times outer, plus 4x, plus inner times inner, x, and last times last, which we get 5x squared plus 19x plus 12. Is that what my original equation is right here? Yes, it is. So this is how you factor. All right. That's the grouping method. To me, that's the one students have the hardest time with. The next method is called the box method. So you're still going to find K1 and K2, and we said there were 4 and 15, except for now, so we still do the same. Put in standard form, identify A, B, and C, make your little cross A, C, B, and it's 4 and 15. So that doesn't change. So now we're going to make a box with 4 squares. So we're going to put the quadratic term, so quadratic term here. So I don't have term. We're going to put the constant term here. And then guess what's going here? K1 and K2. Okay, so this is your little formula for the box method. So now I've said K1 is 4 and K2 is 15. It doesn't matter which one. You could have switched them around. It doesn't matter. But the quadratic goes here, term, and the constant term, not just the coefficient, but the whole term. So now what do we do from here? Well, so we write our box. What is our quadratic term? Remember, it's part of vocabulary, 5x squared, and then 12. And then I'm going to put 4 and 15. So now you look at row 1. Do they have any common factors? Yes. Oh, sorry, you can't forget the x because they're linear terms. It's not just the coefficients, it's the whole term. All right, so we're going to factor out a 5 and an x. In this row, I can factor out a 4. And this row, I can only factor out an x. Here, I'm going to factor out a 3. I'm going to factor out the greatest common factor. So now, this is going to become x plus 3 times 5x plus 4. And that's exactly what we got when we did the grouping method. You can check it if you forgot by FOILing this, and you should get this original, which we did. Now, this method is pretty easy. What makes it complicated is when you have a negative here, or both. Then you have to be able to factor out a negative, and you got to make sure that your signs are right, that you factored out a negative where you should have. Sometimes you might have a negative here and a negative here. Well, I don't have any negatives, so if I have 2 negatives, but neither one of them are in the same row or the same column, then I factor out a negative here and here. Okay? It gets complicated, and if your signs are, and then you check that by doing sign. So it can be a little complicated when you have negatives. So that's why I like this one better than grouping, but it can be a little tricky with the negatives. My favorite is a California method. It follows this, but you don't have to think too much. So again, you're going to put it in standard form. And I do have, and I will post this on Google Classroom, the California method, the instructions. This is by far my favorite. So, whoopsie. What did I do? Oh, here we go. So let's look at the California method. Okay, you can pull up that sheet and you can print it out and make notes on it if you want to pause the video. So, California method. Step 1. We're going to put in standard form, identify A, B, and C, make our little box chart. It's still going to be A, C, B, K1, K2. This is the same for whether we use the grouping, box method, or California method. So we said K1 is 4 and K2 is 15. So that's step 1. So you're going to find K1 and K2. Step 2, you're going to do x plus K1 times x plus K2. So x plus 4 times x plus 15. Step 3, we're going to take K1 and divide it by A. So x plus 4/5 times x plus 15 over 5. So this simplifies to x plus 4 over 5 because it's not a 5 is not a factor of 4, and this simplifies to x plus 3. If they're not integers, if you don't end up with an integer for K1 and K2, then the denominator, 5, just simply moves here, so it becomes, that's step 4, so it becomes 5x plus 4 times x plus 3. And this is what we got the first 2 times. And we can check it again by doing the FOIL method. So the key here is K1 over A and K2 over A must be integers. If they're not, if the quotient is not an integer, then you take the denominator and it becomes the coefficient of that x. And there's your factoring. That's the easiest method to use. So stop the video. The last page is 2a and 2b and 3. So I want you to do all these and factor them. You can use any method you want. You can use each method for each one separately, or you can do all 3 methods for each one to see if you can do them, or just simply find the best method that you like for factoring. All right, see ya.